have three types of storages, and they fall under two main categories. One being the SAN storages, and the other being the file storage. The SAN storage stands for Storage Area Network, which means it's a storage type that can be accessed over the network. And under the SAN storage type, we have the object and the block storage. And we say the block storage is a storage that takes your data and it breaks it down into blocks. And you can store it wherever you need to store it to have an increased performance. And with a block storage, you can increase your storage capacity because you can put multiple block storages together for either increased speed, increased storage, or more performance. And that configuration is referred to as RAID. And something to note with the block storage is you can actually attach it to your host device or your servers, and you use them as booting devices. So you could use them to boot your servers or your devices. So under the SAN storage, the other type of SAN storage we have is object storage. The way object storage operates is it takes your data and it breaks it down into objects. Now, the peculiar thing with the object storage is those objects, they have information about those objects, and this information about the objects is referred to as metadata. So that is data about the data. That is referred to as metadata. And with that property of the object storage, it is employed because you can use that to query data in an object storage using the metadata. So that's an advantage the object storage has. And with the object storage, it has a property known as versioning, where the data stored in an object storage system or an object storage type, whenever the data is updated or edited, a new version of that data is being saved. And with that property, you can easily use all the storage capacity you have in your system if you have versioning that is turned on for frequently accessed data. That's why for frequently accessed data, a lot of the times they'll use block storage, because block storage doesn't create a new version whenever you update or edit your data. The other type of storage we have is the file storage. So this is a storage that is attached to your host or your server. And with this file storage, we have two main types. We have the NFS or the network file system, and we have the SMB, which is the saver message block. You primarily use a file system or file storage whenever you want multiple devices to access a particular information or a particular data set concurrently or at the same time. That's when you employ the file storage. For the file storage, the NFS or the network file system, you use that when you're dealing with Linux or Unix systems. And for the SMB or the saver message block, you use that when you're dealing with Windows systems. And along those lines, we saw that for you to be able to use these storage types, you ought to have data to store. So we looked at the different types of data we have. We have structured data, we have unstructured data, and we have semi-structured data. So with the structured data, there is a relationship between the data that you're storing. So you have some sort of an organization or a structure within the data, or a pattern within your data. An example of a structured data will be an Excel data in an Excel sheet. That's structured data where you have one aspect that relates to another aspect, where you can associate different aspects within that storage system. That's an example of a structured data type. With the unstructured data type, we saw that it lacks a predefined structure, and you need a special tool to analyze this data to be able to draw insight or information from this data. And examples of unstructured data sets, you have documents, pictures, videos. These are just some examples of unstructured data. Now, for semi-structured data, we saw that semi-structured data is data that is stored in a JSON format. And with this semi-structured data, there is a certain level of structure within the data, but you have to analyze it before you can pull out the structure, from that data. And we saw an example of a semi-structured data being the example of a JSON file that has maybe somebody's name, their ID, the date they made a purchase. So that's just an example where you have that in different blocks, but they're not categorically in a specific form. So you have to analyze it, then you can discover the structure within that data. We have different databases. A database is simply an organized or structured form of storing data or storing data electronically in a storage. So that's what a database is. And for you to be able to control a database, you need a database management system. So you use a database management system to control your database. And combining your database and your database management system, that gives you a database system. But in short form, they call it a database. And once you have these different data types in different databases, you need a component which you can use to gain access to the data within these databases. And that component is a software component, and that's referred to as a database engine. This data, we saw that once you have this data, there are two major processes which you can apply to this data. And that could help you determine which database you're using to store your data. So the first one was the OLTP, which is the online transactional processing. And this type of processing is used to update, to insert, or to delete data transactions. And an example of this we saw was the bank situation, where you go execute or you perform a transaction, and it has to show that transaction within your bank account. So it operates using the OLTP processing. And the other processing was the OLAP, which is the online analytical processing. So this is used for historically stored data, to analyze the data, to gain insight on that data you have. Okay, so with the OLAP, you can use it on different data types. We talked about the different types of databases we have. The first one being the relational database. And we saw that the relational database, you use that when you want to store variables that have a relationship. Relational database operates on the OLTP processing format. So it uses the online transactional processing. And we also saw that relational databases are ACID compliant. And on the ACID, the A stands for atomicity, the C stands for consistent. So atomicity, you have all or nothing. So a transaction either goes all the way or it doesn't go at all. You have consistency for the C. So once the system commits to a transaction, it has to confirm to the schema. So once it starts a process, it has to finish it. The I stands for isolation. So multiple transactions, even if they are started at the same time, they are treated as individual transactions. They do not interfere with each other. And D was durability. So whenever you have your data in a relational database, it is durable. So if one system fails, it is always available in another system. So you cannot retract a transaction or process that had occurred once it has been completed. And we saw that in the AWS platform, or on the AWS platform, they refer to the database as the Amazon Relational Database. And we also saw that there are different examples, or there are several examples of relational databases, some of them being the Microsoft SQL, the Oracle, the Postgres, and there are many more relational databases. And we saw that besides having a relational database, we also have a non-relational database or a NoSQL database. And the no before the SQL on a non-relational database stands for not only SQL. So that means we can deal with structured data, we can deal with unstructured data, and we can deal with semi-structured data in a NoSQL or a non-relational database. We saw some examples of non-relational database being DynamoDB, the DocumentDB, the Neptune, the Graph,